Hello everyone, today's problem is to find the sum of XOR of all the subsets of a given list of numbers. So let's understand the problem. So first of all, the XOR total of an array is defined as the bitwise XOR of all the elements. So if we have numbers, let's say 1, 2, 3 in a list, then we take 1 XOR 2 XOR 3. So here we do bitwise operation. So 1 is written as 0, 0, 1. 2 is 1, 0 and 3 is 2 plus 1. Yeah. So we know that if we take XOR of 1 and 1, it's 0. We take XOR of 0, 0, it's 0. XOR of 1 and 0 is 1. 0 and 1 is 1. So if there are odd number of 1s, then it's 1. If both are same, 0, 0, then also 0, 1, 1, then also 0. That's why it's called exclusive OR. In OR we have either 1 or both are 1, then we take 1. So we are given a list of numbers. We have to find all the subsets. So if we have n elements in a list in general, there are 2 raised to the power of n possible subsets. And why is that? Because for each of the n numbers, we have 2 choices. Either pick it or do not pick it. Let's say if we have 3 numbers, and then in the first case we do not pick it. So with these 2 we can have 4 possibilities, and the same possibilities append the first number. This time pick the first number. So these 4 possibilities are fixed. So you can double that. Similarly, you start with 1 number. So one possibility is that, let's say it's A, and other is we do not pick A, so it's empty. Now we add another number. So with 1 we have 2 possibilities. We have another number, we pick it or do not pick it, and we include both the cases here. So you keep on doubling. So you have 2 multiplied by 2 all the way up to n. So you get 2 raised to the power of n subsets. So you have to find all the 8 subsets in this case. So you take one subset, take XOR of all the elements. You take another subset, you take the XOR of all the elements. So XOR will result in some value v1. Here it will be, let's say, v2. So all the way up to v8. And then finally you have to sum v1 plus v2 plus all the way up to v8. So this is what you need to do. So let's see an example. So let's say our example is 516. So I have listed all the possible subsets. So this is empty set. Here we include, these are the sets of 1 elements. So 0 elements, 1 elements, 2 elements and 3 elements. All the possible values. So XOR of nothing. So there is nothing here. So here XOR is of this set. This is a set in itself, is 0. These are single elements, so XOR will be those numbers themselves, 5, 1, 6. Now we have two numbers. So 5 is 1, 0, 1 and 1 is 1, 0, 0. So this becomes 0, this becomes 0, this becomes 1. So it's 4. So here the value is 4. Next, 5 and 6. So 6 is 5 is 101, 6 is 110. So 110, which is 3. So here we get 3. And then 1 and 6. So we get 7. And then 1, 6 is here, then 5, 101. So here we have 2 1s, so 0, 1, 0, which is 2. So here we get 2. So the sum is 5 plus 1, 6, 6, 12, 4, 16, then 10, 26, and 2, 28. So the result should be 28, and which is what is given here as the output in the sample. So if you understood the problem now, we can go on to how to solve it. So let's see a pattern. So if we take any number, if let's say you take 5, and we know that there are 2 raised to the power of n possible subsets. So, and how was it formed? If we take n minus 1 elements and then whatever is the number of subsets, we double that. In one case we do not include it, and in other case we include this nth number and the same all subsets. So 5 or any number will be present in half of the subsets. So you count here, total there are 8 subsets. See how many times 5 occurs. 5 comes here, 1, 1, 2, 3 and 4. Similarly you can check for anything, 6 also, 1, 2, 3, 4. Similarly 1, 2, 3, 4. So all the numbers will be present in half of the subsets. So if you had to take this cumulative XOR, you would have simply know that each number occurs even number of times. So ultimately XOR will be 0. But this is not the case. You have to do within a subset. Within a set you have to take XOR of all the elements. A set can have 0 or up to n elements. So in this you take subset XOR of all the elements here also, and then finally add. So now how we can intelligently arrive on some bit pattern. So we know that let's say we are looking at a number, let's say 5. So in 5 we know that the bit pattern is 1, 0, 1. And 5 is present in 2 raised to the power n divided by 2 subsets. So finally we are adding them. So when we add, what happens? When we add two numbers, let's say 101, which is 5, and 6, let's say 110. So 10 is 1, no carry, no carry. Here 1 plus 1 is 0. There is a carry of 1 which will come here. So if any bit occurs 2 times, so if you have 1 1, it becomes 1 0. So 1 is nothing but 1 and 1 0 is nothing but 2. So it doubles because it occurs 2 times. If it occurs 4 times, 1 1 1 1, then you get 4. And what is 4? It's 1 0 0. So if any number occurs 1 times, it remains that. If any bit occurs 1 times, then it will be same. If it occurs 2 times, it's 1 0. If it occurs 4 times, it's 1 0 0. If it occurs 8 times, it's 1 0 0 0. So basically you are left shifting it when you double the number of bits. So here we know that all the numbers are occurring even number of times. 2 raised to power n divided by 2. And this is some power of 2. So divided by 2 is also some power of 2. 2 raised to power n minus 1. So of course for base case n equal to 1, we know that XOR is simply that number. So we are not worried about the base case. We are talking about larger values of n. So this is some power of 2. So all the numbers are occurring even number of times. So we are not concerned with odd cases. That's why I was listing even cases. That if 1 1 occurs twice, it becomes 1 0. If it occurs 4 times, powers of 2. Not just even, but powers of 2. So 1, 2, 4, 8, 16 and so on. So if it 4, then 1 0 0. If 8 times, then 1 0 0 0. So every time shifting left by 1. So this is what you need to keep in mind. Now let's see. So let's talk about 5. So we know that 5 has occurred 4 times, n by 2 raised to power n by 2 times. So finally when we are adding, we follow this thing, that how many times a particular bit has occurred. Now we have all the knowledge required to solve this problem. So now focus on a few key things. First is that all numbers, all AIs, so AIs are nothing but this 5, 1 and 6, and this array A, occur 2 raised to the power n minus 1 times, because there are 2 raised to power n sets and they are present in half of them. And so if a number AI occurs 2 raised to power n minus 1 times, let's say this is the pattern for this number AI. In this case it's 5. So here bits at position 0 and 3 are occurring. So these bits are also naturally occurring 2 raised to power n minus 1 times. So and the second point is that if a particular bit, so let's say we have a long number and we are looking at a particular bit here and there are ones, this bit is set. So if it's occurring 1 1 1 1 p times, then we were looking in only powers of 2, so let's say it occurs 2 raised to power p times, then it's equal to, this bit will be left shifted by p steps. So that will be, so if this bit was here, it will go p steps to the left. We saw with example at this 1 1. So if we were 4, 2 raised to power 2 is 4, then it's 1 0 0. So it left shifts by 2 steps, you see. So it left shifts by 2. So this bit left shifted by p steps. So these are the two things. Now which bits are set in the original number? So if you take OR of all the numbers, then what is OR? It says that if that bit is set in any of the numbers, it will be 1 in the output. So if you take OR of all these three, you will get a number, you will get which all bits are set. And then you know that all of these bits will be occurring 2 raised to power n minus 1 times. So whatever is the resultant OR, you left shift by n minus 1. So 5 is 1 0 1, 1 is 0 0 1, 6 is 1 1 0. This, there is some 1 here, so 1. We don't need to count, just if there is any 1, then it's 1 1 1. So we know that in the input there was some 1 occurring in at least one of the numbers. Similarly, second bit is also set in some of the numbers, third bit also. So this is the result of taking OR. And then we left shift by 2 because n is 3, so n minus 1. So 1 1 1 0 0. So what is this value? This is nothing but 16 plus 8 plus 4 plus 0 times 2, 0 times 1, which is 28. So I hope you understood this concept. Now let's write the code for this, which will be very trivial. So first define, the result will be, let's initialize to 0. Then for first we take the OR, and then let's also calculate n. Then return result left shifted by n minus 1 times. So the logic is important. The code is just a couple of lines. And it passes all the test cases.